Alright, in working with percent change, we have 4 variables, 4 quantities we might be interested in. They are f, the final or ending value of our quantity, c, the change in our quantity, s, the starting value of our quantity, and p, the percent change. Now we know that the percent change is the change expressed as a percent of the starting value. That is, according to the percent equation, using c as the portion and s as the base, we have c equals p times s. Remember, if you're going to do calculations with it, your percent needs to be expressed as a number. So, the percent equation using c as the portion and s as the base gives us that the change equals the percent change times the starting amount, which is great if that's what we know, right? Typically, however, the variables that we're really going to be interested in are the final value, the starting value, and the percent change. Typically, the change is just something that we're going to stop off at on the way. With that in mind, let's take a minute and work with this formula and see if we can get some formulas that are going to work for us a little bit more easily. Right now, we know what the change is in terms of the final value and the starting value. The change is the final value minus the starting value. So that means the final value minus the starting value equals the percent change times the starting value. Now we're going to use this formula in order to find percent change. So I want to actually take one extra step in manipulating it. I want to go ahead and multiply both sides by 1 over s. Notice I'm making an assumption that the starting value is not 0, since I can't take 1 over 0. But none of this makes any sense if the starting value is 0, so that's okay. The s and 1 over s cancel out, of course, and I'm left with p equals f minus s over s. I'm going to call this formula formula number 1, and I'm going to use this to calculate percent change. So let's see an example of using this formula. Suppose we're told that a population goes from 18,975 in 2006 to 14,750 in 2016. Find the percent change. Round to the nearest tenth of a percent. So, the final population is 14,750. The starting population is 18,975. And the percent change is what we want to find out. Using formula number 1, the percent change is the final value, 14,750, minus the starting value, 18,975, all over 18,975. Now this is absolutely arithmetic that I should use the calculator for. First I'm going to do the subtraction. 14750 minus 18975. I notice I got a negative number, which I expected. So I'll have negative 4,225 over 18,975. Let's do that division. So this is something like negative 0.226, etc. I think I copied, I copied one too few twos. 2226, etc. Now we're told to round this to the nearest tenth of a percent. So I'll multiply by 100. 22 point, round up to 3. So we get negative 22.3%. How do we understand that negative number? Well, that's a negative change, which just means the population decreased. Okay, so that's an example of using Formula 1. Let's back up a little bit and see if we can find a formula now that will be convenient when we want to calculate the final amount or the starting amount. Because this formula is going to be kinda awkward to find the final amount and very awkward to find the starting amount. Okay, so where did we start? We have these 4 variables that interest us, and just from the percent equation we know that the change is the percent change times the start. Now earlier we got rid of the change by saying that change equals final minus start. Now we're going to use a different version of that equation that says that final equals start plus change. How does that help us? Well, we're going to take the change and substitute this expression that we know is equal to the change to get the equation final equals start plus percent change times start. Okay, we're almost done, but we're going to manipulate this just a little bit. Remember that start is 1 times start. And now, if we think of s as our variable, we can think of these as, well, they're both something times s. That's kind of like being like terms. Let's use that fact to rewrite this equation, adding together the coefficients and then multiplying by s. Right, you can see that going this way is just the distributive property. 1 times s plus p times s is the same as 1 plus p times s. That gives us what we'll call Formula 2. The final value is 1 plus the percent change times the starting value. Where did we get that adding 1? That is just adding in the starting value to the change. We will use this formula when we want to find f or s. So, for example, we might be told, suppose the price of a certain product increases by 10% each year, and we know it cost $855 in 2009. How much does it cost in 2010? Well, we know the percent change is 10%, which is 0.1. That 855, is that the starting value or the final value? Well, 2009 comes before 2010, so 855 must be my starting value. I get that my final value equals 1 plus my percent change times my starting value. Okay. And my starting value, we said, was 855. So 1 plus 0.1 is 1.1 times 855. Let's calculate that. 1.1 times 855 is 940.5. So let's see, the price is $940.50. Okay, let's think about the same product, but now let's ask, how much did it cost in 2008? Now, 2008 comes before 2009. So now 855 is going to be my final amount. I'm going to have my final amount is 855, and my starting amount is what I want to find. My percent change, still 0.1. I'm going to find that 855, my final amount, is 1 plus 0.1 times my unknown starting amount. Okay, we can still do this addition. 1.1 times S is 855. But now we need to use algebra to find S. We'll multiply both sides by 1 over 1.1. You can think of this as dividing both sides by 1.1 if you'd rather. Here, these will cancel and we'll be left with S. On the left, 1 over 1.1 times 855 gives us, 777, let's round that to the nearest penny, 27. So we get 777.27. Right, these are now approximately equal. $777.27 is how much it cost in 2008.